Okay. Hello everyone. Welcome or welcome back to the Next Level FAANG YouTube channel, your one-stop destination for all upcoming FAANG interviews. Today we are solving another very interesting problem, which is the robot room cleaner problem. So this problem is a Leetcode premium problem and is very interesting to solve. So let's get right into it. This is a little long problem, so please pay attention now. So you are controlling a robot that is located somewhere in this room. The room is modeled as an M cross N binary grid where 0 represents a wall and 1 represents an empty slot. The robot starts at an unknown location in the room that is guaranteed to be empty. Okay. And you do not have access to the grid, but you can move the robot using the given API robot. Amazing. So you are tasked to use the robot to clean the entire zone. That is, clean every empty cell in the room. The robot with the four given APIs can move forward, turn left, turn right. Each turn is a 90-degree turn. When the robot tries to move into a wall cell, its bumper sensor detects that obstacle and it stays on the current cell. So we need to design an algorithm to clean the entire room using the following APIs. So the APIs are said to be, the first one is move. So it returns true if next cell is open and robot moves into the cell, and returns false if next cell is obstacle and robot stays in the current cell. Understood? So move is basically letting the robot move in the forward direction if the cell is open. If the cell is an obstacle, it stays in the current cell. Understood? So the next one is the turn right and turn left. So both these will enable the robot to stay on the same cell after calling turn right or turn left. Each turn will be a 90 degrees turn. So calling these two APIs, it will not actually move the robot in any direction. It will just turn the robot 90 degrees either towards the left or the right direction as said. And void clean basically cleans the current cell. So these are the four operations we can perform. Note that the initial direction of the robot will be facing up. You can assume all four edges of the grid are all surrounded by the wall. So we have a grid, and the grid is also surrounded by a wall. So the robot cannot move beyond the grid as well. So that is also something we need to keep in consideration. Custom testing, the input is only given to initialize the room and the robot's position internally. So you must solve this problem blindfolded. In other words, you must control the robot using only the four mentioned APIs without knowing the room layout and the initial robot's position. So we need to solve this problem blindfolded is what this custom testing part is saying. So now let's get deep into the problem as we have finally read and understood what the problem says basically. So what is our goal? The goal is basically to clean all accessible cells in the unknown room grid. We just need to clean all accessible cells in the unknown room grid. So when this goal will be fulfilled, our code will successfully pass this problem. So we need to pursue this particular goal. There are some constraints given. The grid layout is unknown. The robot's starting position is also unknown to us. So we don't know at exactly which cell the robot is starting out. So robot only knows how to move, which is forward only if possible, which means that if the forward direction is a wall, it cannot move. And if it is an empty cell, then only it will perform the move function. Then we have turn left and turn right, which is 90-degree in place rotation of the robot and no movement. Next is the clean, which helps to clean the current cell. Now, looking at this, a classic brute force approach is not a solution because we are solving this problem blindfolded and the grid is not actually available to us. So we cannot perform like a well-structured traversal and keep visiting each and every cell and then performing the needful. So what we can do is we can perform a blind traversal instead and keep a track using a visited set, let's say, and then keep the traversal on until we have cleaned each and every cell of the grid. So the approach which I can think of is a DFS backtracking approach, where first we'll clean the current cell we are on. Basically, we'll make the robot clean the current cell it is on. And we can use a visited set to avoid revisiting any cell which has already been cleaned. We'll try all directions. Like if we are starting from a particular cell, we'll try all the directions which are connected to the cell, which is up, right, down, left. But as we move forward, we'll also know how we'll be doing that. If the move succeeds, now success of a particular move depends on whether the next cell we are trying to visit is either wall or is an empty cell. So we recurse deeper. And if after recursion, we go back, which is we basically backtrack to the previous cell and orientation we were at. We also have a grid here, which basically shows us that all these ones are empty cells, and we have a wall here as well. So this is the grid that we will be using for simulation of the approach. And the robot here starts at 1, comma 1, which is the center, which is unknown to us, by the way. This is just for the simulation purpose. So I've also drawn this so that we can understand it better together. So this is the place of the robot. This is the coordinate where we have a wall, and rest is the empty cells which we are required to clean. Now, how we are approaching the direction part is that we have assigned direction as 0, 1, 2, and 3. Now, 0 is assigned, up is assigned to 0, which is basically moving up will be denoted by 0. Moving right will be denoted by 1. Moving down will be denoted by 2. And moving left will be denoted by 3. So let's see how we will clean this entire grid using the approach that I just talked about. So step one, you start at 0, comma 0. Anywhere the robot is, we'll take that coordinate as 0, comma 0. Actual here is 1, comma 1, but that is not known to us. So we'll start at 0, comma 0. We'll call backtrack, which will take the coordinates along with the direction it is facing right. So since we are starting facing up, so the direction is taken as 0. So we'll mark, so first we'll mark 0, comma 0 as visited. We'll add it to the visited set. We'll clean the current cell we are on, and then we'll start trying directions up, right, down, left in the clockwise manner. So step two is basically first we are trying up because we are trying with directions up and move succeeds. As in when we call up move, it succeeds because it is an empty cell and the new position is now this particular cell which is in actual senses 0, comma 1. And we'll call backtrack with the new position which is minus 1, comma 0 as up is assigned to minus 1, comma 0. And we'll call backtrack with that coordinate and we are still facing up, so the direction will be 0 and we'll mark it as visited and is clean. Now trying right, the move succeeds again. We call backtrack with the coordinates. Now this time facing right, we mark is visited and clean. Next trying down, down also succeeds because it was an empty cell. So it calls backtrack again with the coordinates 0, comma 1 along with the direction which is down in this case. We mark it as visited and we clean the cell. Then we try down again, as we can see. As in when we are cleaning a cell, I'm changing the color to green. So we will call backtrack with the coordinates in the direction and mark it as visited and clean. Now, step 6. Now, this is when things get interesting. So in this case, all directions fail now because here, as we can see, it is a wall. Rest, it is surrounded by all visited cells, and grid itself is surrounded by a boundary wall. So now in this case, we only thing we can do is backtrack. Now, how we are backtracking is we'll turn right, make the robot turn right twice. So it now faces the opposite direction. Try to visualize it with me. If we turn right twice, we move once, we turn right twice. You will know that we actually fall in this place again. Now you can try visualizing again. We turn right couple of times. Turning right is just move, changing the direction of the robot 90 degrees towards right twice. This is basically 180 degrees in total, and it faces the opposite direction now for the movement to the previous cell it was on. And then we turn right couple of times again. Why? So that now we restore the original facing direction. This is how go back is working. So now we are back to the previous cell we were on. Now again, it's the similar case. We are all surrounded in the all four directions. We are surrounded either by already visited cells or by like this wall, the boundary wall. So we backtrack again. Now again we backtrack a couple of times, but this time when we backtrack, we can actually see that the left position is an empty cell which is not visited yet. So we call backtrack again with the new coordinates now, along with the direction, which is left, which is denoted by 3. And we clean it again. We again move down, clean the cell, and then move down again and clean it further. So this is how we achieve the entire grid cleaning up section. And now how to figure out that now it is finally succeeded to cleaning all the cells. So now as we backtrack again, all directions failed, we call go back again. We backtrack, all directions tried, failed, and we call go back again. Now we backtrack finally, and we are in the direction and in the particular cell we started with. So now all directions are exhausted. We have no direction to go to. And now final DFS return takes place, which means that the entire grid has been successfully cleaned and we have achieved what we wanted to achieve. So now what is the time complexity of the solution? So it is big O of n because number of open cells we have visited so far, and space complexity will be for the recursion stack and the visited set we are having. So it contains all the empty cells again. So it will be big O of n again. Now I hope you've understood the approach entirely. So now let's get to the code. So this is the code to the discussed approach. So this is the class robot, which is the robot's interface as defined in the problem. We assume that the real robot class will implement this. So we have here move, which is basically moving the robot forward by one cell in the direction it is facing. So it returns true if the next cell is open. If not, it returns false as it is a wall. Next is turn left, which basically turns the robot 90 degrees towards left. Then we have turn right, which basically turns the robot 90 degrees to the right. And then we have the clean function, which cleans cells the robot is standing on. Next, we have the direction vector defined here, which is simulating the movement, the directions up, right, down, left. And this also represents the rows and column changes respectively that we'll be having. To keep a track of the cells that are already visited, we have the unordered set here called visited, where we'll be adding positions as string like 0, 0, 1, 2, etc. This is the pointer to the robot instance. So now we have the main function, which is to start cleaning the room. So we have this clean room function where we start the DFS from the position 0, 0, and we facing the direction 0, which is up in this case, as this is in the question also it is given that initially the robot is facing up. So then we have this backtrack function, which takes the row index, column index, and the direction. And then there's a position key where we convert the current position to a unique string key. And then we check if the visited set has this pause key present in the set. If it does have it, then we skip it. So now how is it making sure if the count of this pause key in the visited set is 1, then we skip that particular cell and mark, if not, we mark the current cell as visited. Then we clean that particular cell. As we were discussing in the approach also, we were following this pattern only. And then we try moving in all four directions in a clockwise manner, which is up, right, down, and left. So we have this loop running from 0 to 4. The new direction will always be under 4, and this modulus 4 will make sure that the direction is always between 0 and 3. And we calculate the actual direction and store it in new dir here. And then we get the row and column deltas for the new direction using this particular formula. And then we only move if the new cell hasn't been visited and it's not a wall. Now, how we are checking that? If visited not visited dot count new row plus new string, which is basically generating the pause key again, and robot move, which is the API, as giving us true, then both the conditions are true. Then we recurse from the new cell, giving the new direction. And then after exploring the new cell, we go back to the original cell as we were backtracking, going back if when there was no possible direction to move at. And then we turn the robot right 90 degrees to face the next direction. That's what we are doing. And now let's see the helper function, which is the go back function. So that helps us to backtrack and just go back to the previous state we were in, the robot was in. So we basically turn the robot 180 degrees as I was telling, like turning the robot 180 degrees is actually making the robot face right in the opposite direction. Then the robot moves forward. That is moved back to the previous cell the robot was at. Then we turn 180 degrees again to face the original direction because to go back to the previous cell, we did change 180 degree of its direction. So we changed it back so that now the robot is facing the previous direction again. So this was the entire code. I hope you enjoyed the problem. So the time complexity of this code was big O of n, which is number of the empty cell, as we discussed in the approach as well. And the space complexity is also big O of n, as we are keeping a track in the visited set and also combining the recursive stack here. So I hope you enjoyed the video. I hope you enjoyed the solution and understood the solution as well. Do give this video a thumbs up and also let us know in the comments what next questions you would like us to solve in this particular channel. Thank you so much.